I'm Michele Whitfield. I'm the marketing manager at Centrisys and CNP. Before we get started, I know we gave you guys a 30-minute time frame, and I want to keep to that, so I'll be quick. But I think what I need to do very quickly is just give you a brief overview of Centrisys and CNP. So Centrisys started in 1987. We're a U.S. manufacturer of centrifuges. We started as a service company. Michael Kopper, who's also in this picture, came over from Germany. He worked for a company called Humboldt, started in Los Angeles, worked around the country doing service for Humboldt. And early on, like when did Humboldt go out of business? When? In 1982, Humboldt went out of the United States. 1987, Humboldt went out of the United States, and Michael decided to stay here. He saw the opportunities here, especially in service for centrifuges. So in 1987, the company started. What's interesting about that picture is, so that's 1987, there's still 5 people that work at Centrisys in the photo. So in 1987, Centrisys started as a service company for centrifuges, eventually moving into manufacturing. The first centrifuge was built for Honolulu, Hawaii, still running there. In 2019, today, we have 3 buildings in Kenosha, one for service, one for new production, and one for parts. So we've grown quite a bit just with centrifuges, but in 2014 we started a new division. We had the opportunity to buy a technology in Germany called Airprex. And Michael saw a tremendous opportunity, especially in the United States with the struvite and phosphorus and everything, so he decided to bring that company along. With that came Gerhard Forstner. So this is where the Centrisys CNP comes together. It's equipment along with the treatment process, which really just makes our team very strong. That sort of optimization of the equipment in order to optimize the process makes us, what we think, biosolids experts. So anyhow, along with that, we've started to bring in other companies, mostly European companies that don't really have a footprint in the United States, but we feel they're very strong. We have Pondus, which is up here, which is a thermochemical hydrolysis process. We have Hydrograv, and then we have LIP, which is a tank and digester company. But so along that lines, I am going to have Michael start to talk about some of our important installations and what's happening with our centrifuges.
Good morning, I'm Michael Kopper, and I'm supposed to start talking about centrifuges. When I came to the United States, the centrifuge industry was very small. Even today, Centrisys is the only manufacturer to manufacture centrifuges for the environmental market in the United States. We then learned very quickly we compete against a lot of other companies coming from Europe and things like this, and we as a small company had to compete. How can we compete against the big competitors? And the biggest advantage we have, we were small, we were flexible, and we learned things and we put it right into the operation. If you look at our big installations we have right now, taking New York. New York is the biggest centrifuge installation in the United States right now, and little Centrisys won the order by being power savers, being the better company overall. We were not the cheapest in CapEx, but we were the cheapest in overall cost. So if you look at the power consumption by installing the centrifuge in New York was, we reduced the power by 50% for the same flow rate, which was an advantage overall. Even so, power is still inexpensive, will get more expensive in the future, but it is a big savings. Also, it decreased the carbon footprint for New York, which every big cities right now is an incentive of reducing carbon footprint. And by reducing the power consumption, New York was able to reduce the carbon footprint. The same thing happened with the lower polymer as well as lower power costs. We have jobs in Denver and all other cities as well. Based on that, we looked at the thickening market. The thickening market basically, historically, we had centrifuges there, but then it went over to bell presses, rotary drum presses, but again, by doing so, the amount of polymer has increased, but tremendously. So we looked in what can we do to develop a machine where we reduce polymer, reduce power, and increase liability. So then we developed the THK machine, which is actually specifically designed for thickening. It is not a machine where we took a dewatering machine and modified it and made it a thickening machine. We made it a strict thickening machine, and the intention were to operate without polymer. Again, it is overall reducing carbon footprint for all the cities. So now we have installed the thickening machine in several installations. Our first installation were Kenosha, where we are home. We have a very good relationship. They helped us out. We could test there. We could do everything. It's our test ground, our playground. And we have now installed machines everywhere in the US, in China, everywhere on the THK. Why did we develop the THK is for cost savings for the client. It's basically a machine which runs without polymer, or with a small amount of polymer, we can double the flow rate. What does that mean? It means basically a city doesn't have to buy a second machine for standby. The standby could be just a small amount of polymer. When I mean a small amount, I'm talking about 1 to 2 pounds per dry ton, which is not a big expense for doubling the flow rate of the centrifuge. So that's what we have done. Then the same thing on the power consumption. We minimize the power on the THK centrifuge for thickening. The power consumption basically is half of what a normal dewatering centrifuge is. And that is because innovative design of liquid and solid discharge on the smallest diameter, we don't destroy any energy, and so it's half the amount. If you think about it, we have about 0.1 horsepower per gallon, which is very, very good per hour. So that is basically where we are, the lowest power consumption from any machine on the market to operate. So that was our incentive to do things. That's why Centrisys is on the forefront of having centrifuges in the market. We are innovative, we are quick to put it on the market, and we take some risks to go there, but it has rewarded us over the time, starting in 1987 with 2 people, and right now we have 150 people employed and manufacturing everything in the United States for us so far. So that helps us to be where we are. All right, and so based on all of that, like Michele said earlier, we had the centrifuges is our main product, the product we love, but then we said we can't be standing on one leg. We had to add something on process. So that's when we went for the process part. We basically took processes like ponders, like air pracs, like cowl pracs, like hydrograph in our portfolio. So we have experts at the processes in the biosolids industry. So with that, I probably give it to you. You can say what's the new and the best there. This is Gerhard Forstner.
Thank you, Michael. So thank you all for coming. Good morning. So we talked about the focus. Michael talked already about energy savings and how our focus is on really creating a more sustainable treatment plan. In 2014, we had an opportunity to bring a technology over from Europe called AirBreaks, which is a phosphorus recovery technology. We thought it was a perfect fit because it really fits into the biosolids. It recovers screw-wide phosphorus before dewatering, to optimize dewatering performance. And so we were fortunate to put that in. Okay, there you go. So, and CNP, what does CNP stand for? So our focus is carbon, nitrogen, and phosphorus. It's it closes the loop. We really want to create energy neutrality for treatment plants. And we have done a project in Kenosha, Wisconsin, where the Kenosha treatment plant is energy neutral on a biosolid strain. So we thicken with the innovative thicken from Centrisys. We hydrolyze the sludge, break the cells, create more biogas. We go through a cogeneration process, provide thermal heat to hydrolyze and dry the sludge in a belt dryer, and provide electricity to run our process. So the energy from a 1% dry solids going to 93% Class A product is provided by the solids coming into a plant. So we take any fossil fuel to get the solids from 1% to 93% Class A. And we heat the digest and provide energy to the plant, have excess electricity. So this is really our goal. We're already there on the biosolids and to really be energy neutral. You know, if you would go then to the liquid front with dehumidification, you really have an energy neutral wastewater treatment plant. So we're already there. So our focus now is 3 areas. The one is carbon diversion, which is the hydrolysis process. I'll get to that in a second. But here we are on the B, on the phosphorus. We have on the phosphorus side, we have 2 processes. One is called the airbrake process, which is a well-established process with now next year 7 installations in the United States. The smallest one on a 10 MGD treatment plant, the largest one on a 220 MGD treatment plant in Denver Metro. And what we do is we create basically ideal conditions for magnesium ammonium phosphate or struvite to form after the anaerobic digester but before dewatering. So what you do is when you crystallize the phosphorus in the process and extract it, you improve dewaterability because you remove the phosphorus from your centrate stream before you go to dewatering, and that gives you an opportunity to increase dewaterability of a cake, reduce biosolids, and provide a fertilizer in the form of struvite. So that's the post-anaerobic digestion process. Here's Denver Metro. It's in construction. It will be constructed by the end of the year, started up next year. It's the largest installation in the world. We anticipate to provide about 6 to 7 tons of struvite per day. And this is another installation or in operation in Medina, Liverpool, wastewater treatment plant. This is in combination with a CNP hydrolysis process, but we also provided the lip digester tanks, which is a technology which we partner in the United States. So those are modular digester, stainless steel, which can be built very quickly, and they're very cost effective and were used for this project. That's also in the CNP portfolio. But now I want to talk a little bit about Calbrex. That's our other phosphorus recovery technology. This is a pre-digestion technology. We recover phosphorus in the form of dicalcium phosphate or brushite in front of anaerobic digester. You use a B-release, a fermentation process to solubilize the phosphorus, and then you extract it and crystallize it and recover it from the process. The advantage is you have extremely high total phosphorus recovery rate, the highest in the industry, commercially available. We can achieve up to 50% total phosphorus, between 40 and 50%. Recovery rate, divert the phosphorus before it goes to the anaerobic digester, and create a product, a fertilizer product, which has about 18% phosphorus in it versus 12% in struvite. So it's economically more valuable than a struvite product, and we don't need anaerobic digestion for the process because we don't need ammonia to form the phosphorus compound. So it can be used in anaerobic plants and really other technologies where there's no anaerobic digestion. Also, the really great news we have, this came out of the University Wisconsin in Madison with a group. The company was developed out of soil science department. So our focus was always what we do with the fertilizer. And so recently we got approval for the product by the TNI in Wisconsin that the product is accepted for land application. So now we have a way what to do with the product, which was really important to us. And our team at NIU CNP here managed to do that, so we're quite excited about that. So we can offer a solution to the customer, what we do with the product. We help you to really get some money for the product. Okay, Michele, can you go back? Then the other technology, one of the first one we brought over from Europe is a hydrolysis process. That's right behind me, Bondo's thermochemical hydrolysis. Compared to other hydrolysis processes, this is a low temperature, low pressure process. We use pH change, sodium hydroxide to 11, and we do heat at 150 degrees to break basically waste activated sludge cells to make the waste activated sludge more readily digestible in anaerobic digester. So you cut the hydrolysis process out of anaerobic digester from like 7 days to 2 hours. So what you gain by it, you can increase digester capacity, you get more biogas in your process, and with that, since you have a higher volume solids destruction in your digester, you get better dewaterability because you have less organic content in your solids, you can save polymer, and you can improve dewaterability. We have this implemented in Kenosha, and what that allowed us is to go from about 20, with the Centrisys centrifuges and the thickness there, we go from about 27% solids to 31% dry cake solids, and with a reduction in polymer. And that allows us also, since we go to a thermal drying step afterwards, to have enough thermal energy to get to Class A. So that's really when we talk about energy savings and sustainability. So it could be really used for a small treatment, the smallest installation we have is about a 5 MGD plant, and the largest is going in about like a 50 MGD plant. So this lends itself to small plants and large plants. A simple anaerobic conditioning system. So here, our latest technology from hydrograph, and Dr. Ambrose is here as well. This is probably the neatest and most innovative technology in the secondary clarification arena the last 50 years. So I was told by a leading utility director on the East Coast. What this system does is it addresses the shortcomings of secondary clarifiers, which is really a secondary clarifier, a fixed inlet structure. It's designed for some flow condition, optimized for one flow condition, average daily flow most likely. But what happens when you have low flow? What happens when you have high flow? So hydrograph, Martin's group came out of Martin Ambrose, a hydrograph modeled about 1,000 clarifiers or more, and did CFD modeling on clarifiers to see what happens on a clarifier, where do they work, where do they don't work. And the problem is always the same. When the flow conditions vary, the clarifier is not optimized, and you lose, most cases, especially on high flow, suspended solids over the clarifier via, and with that, particular phosphorus. So, and capacity issues. So the idea how this thing works is, imagine this goes over inlet clarifier well. Oh. Okay, good. Thank you, Michele. So what this system does, it moves the clarifier discharge always in the position where the sludge blanket is. So what we want to do is we want to use the existing settled sludge. So for example, you have a clarifier, you have a sludge blanket, the solid settle, right? Now you have a storm flow, and we discharge about the sludge blanket. So what happens every time we discharge, we disturb the sludge blanket. So the solids, they don't stay in suspension, but they get very turbulence, and then we lose those solids over the clarifier via. What the adapt does is we have a software where we detect where's the sludge blanket in the clarifier position, and then we move the inlet always ideally into the sludge blanket to prevent the minimum energy which we discharge the effluent into the sludge blanket, not disturb the sludge blanket. So you create more the sludge blanket stays in its position. We create the additional volume in a clarifier to load the clarifier higher, and we achieve extremely low total suspended solids and phosphorus limits. So I give you one example, Jeddah Airport in Saudi Arabia, they had 8 clarifiers. They want to expand by 50% the plant. They have also filters for TSS and phosphorus. And the option was to build 4 new clarifiers, but the problem was there was no space. So Martin and his group, they modeled these 8 clarifiers and said, can we put 50% more flow to these clarifiers? Can we do that? And this model said that at 100 simulations, yes, we can. Then the 8 clarifiers were retrofitted with the depth system, and in 2016, 17. And since then, the plant is running, the all the flow, the 50% extra flow to the 8 existing clarifiers. And as another benefit, they're able to shut off their filtration system because the effluent limits are so low that they don't need any filters anymore. So having heard that, HDI engineers did a test in Germany, a stress test to test out the technology, what it can do. And they wrote a report which was published last year at WEFTEC, which you guys can look up. But we approached Hampton Road Sanitation, the Nansemond plant. Some of you may have heard they do a groundwater recharge system, the SWIFT system, in Hampton Roads, where they discharge the effluent into the aquifer. And they need a really good TSS for the system. And their option was, okay, do we build filtration for the tune of $300–400 million for the plant to handle those solids? And they came to Hydrograph and said, can you do that with your Hydrograph adapt system and the model? And we said, yes, it looks good. And based on that, we designed a system which is going to be installed this December to see, if it can maintain the TSS and phosphorus limits and the flow. And once it pans out, all the 12 or 13 plants at Hampton Roads are going to be equipped with this technology to achieve the low TSS. And that will allow them to forego tertiary filtration system on this site with huge savings. We're talking about several hundreds of millions of dollars here. System is very simple. There's a 300-watt motor moving the structure up and down, and there are about now 100 installations in Germany of this technology. So it's well proven and it's well accepted, and it's really a simple system without chemically enhanced secondary clarification performance. We are very interested because it fits in the resource intensification, especially with phosphorus, where it allows us to achieve very low phosphorus limits on the effluent side without using filters. So is there another slide? Okay, so this is our technology which we had to present. I want to thank all of you. We are here, we have the experts here for bonders, hydrolysis. We have Michael Kopper here. Dr. Armbruster is here for hydrograph, and myself. So, any questions from anyone?
So you have CNP, and you talked about carbon, nitrogen, phosphorus. So I can see the phosphorus part and the carbon part. Where is the nitrogen part going to come in?
Charlie, good question. Where's the nitrogen part on the CNP? Yes. So we have. So the question was, where's the nitrogen part, right? We talked about carbon on the hydrolysis, phosphorus on the calbreaks, and on the adapt and on the air brakes. So the nitrogen part comes on 2 places. On our hydrolysis part, we do a project in Germany where we do nitrogen recovery in combination with a hydrolysis process. That's acid with a vacuum degassing process. That's one. And the second portion is we do work with our partner here in Wisconsin University with membranes, nitrogen recovery with membranes. So that work is, we did a full scale on the university, it looks good, but we need to now try to scale it up, and so we should have more data next year. So the focus is really cost-effective nitrogen recovery instead of destruction. Like with a dehumidification, we try to recover it, but as you know, it's been very cost prohibitive to do so. So we try to really go down and make it more economically to recover nitrogen, and that goes in our fertilizer component as well, right? So good question, Charlie. Thank you for coming.